So, welcome everyone. Thank you for joining us today. Today, we're going to be covering Introduction to Azure Virtual Networks in this Learn Live session. I just do want to remind you that you can follow along with these modules. We do have a hyperlink here, https://learnlive/20230601, today's date, and then the letter A. If you have a QR code reader, you can also direct your reader to the QR code. It'll take you directly to this Learn module. Before we get started, I just want to introduce myself, and then I'll also let Jordan introduce himself. My name is Erica. I'm a product manager on the Azure Virtual Networks team, and I'm here calling in from Redmond, Washington. And Jordan, do you want to go ahead?
Yes. Hi, everyone. Welcome. My name is Jordan Parham. I'm a Microsoft technical trainer at Microsoft, focusing on working with our customers and our partners on AZ-104. So that's our infrastructure, along with our architecture and security. So mainly focusing on demos and discussing best practice and overall sharing stories. And I am joining you all from New York City.
Cool. Thanks. And before we get started, I do want to let you know we do have a moderator in the chat. Please say hello to Raman. Raman is my colleague on the Azure Virtual Networks team. And Raman will be moderating any questions you have or being able to redirect to us, and we can take it on the call when we have little breaks between sections. So again, thank you so much, and we're so happy to have you folks joining us today. So again, today we are covering the Introduction to Azure Virtual Networks learning module. So the content that we'll be going through here is all available online. So please do this module on your own. We will be covering these topics really quickly, so we won't get a lot of time to really dive deep. So the modules here, they do include like interactive lab simulations. So that will allow you to really get a better understanding and a better grasp of how to incorporate integrating Azure Virtual Networks into your networking environment. And because it's a Learn Live session, let's take advantage that we are joining from probably many places across the globe. So please do use the chat, build community, let us know your name, let us know where you're calling in from. And yeah, let's just kind of make the use of having this like moment together where we can learn and really get an understanding of virtual networks, and also learn from your peers as well. I'm sure all of you have a lot of experiences of either working with on-prem or in cloud networking environments. So if we can just build on that together, I think that would be great. So feel free, use the chat, put your comments in. We love to see them. Also, along with, where you're calling from, what industries you're working in, however much information you'd like to share here, do let us know what your learning objectives are. Here we have a list of what we've defined as what we hope that you're able to take away from this session. So, learning the foundations of how to implement an Azure Virtual Network, how to configure your public IP services, how to design and implement domain name resolution, design and implement cross-VNET connectivity with VNet peering, implement virtual network routing, design and implement an Azure Virtual Network address translation service. These are the bullet points that we're hoping to hit in this presentation. Again, I'll mention that we won't be able to do really big, deep dives into them, but there are a lot of courses on MS Learn that you can really go into all of these topics on their own. They're all very there's a lot of breadth out there and information. So hopefully we'll be able to get the foundations sorted out in this introductory level course. So thanks again, and welcome all. And we're excited to go into the intro to Azure Virtual Networks with you. So right at this time, I'll pass it over to Jordan, who will be covering the section exploring virtual networks. Also, one last thing, we do have knowledge checks peppered in throughout the sections. So do make sure that you participate. There'll be instructions in each of these questions. So you'll be able to use either your QR code reader and participate in the polls like through your mobile device, or if you want to participate on your desktop, there'll be a hyperlink. So this is a really great way to make sure that like you're retaining the information that you're hearing here, and also just learn, just from the responses and the conversations that we're having in the chat as well. So apologies. Here we go. We're going to start now. Take it away, Jordan.
Awesome. Welcome, everyone. So today's session is all on an introduction to Azure Virtual Networks. And with that, we, of course, want to start off with our initial virtual network within Azure. So when we're referring to a virtual network in Azure, you'll typically hear us refer to it as a VNet for short. So this is going to be the first step when you're designing your Azure solution, as it's the fundamental basis for each of your services. So when you think virtual machine as an example, that virtual machine needs to live in a virtual network. So that's going to be the first step. And if we were to apply this to, let's say, a particular scenario, a use case, your organization is looking to migrate from their on-prem environment into Azure, you're going to start off by creating a virtual network. And the benefit to the virtual network is that it's actually free to create. Now, the resources that you deploy, such as a virtual machine, is going to have a cost that you incur. But with that added benefit of it being free, it's also pretty flexible as far as how you configure your virtual network. But with that flexibility, it's also going to require a bit of planning. And this planning is going to involve your IP address space. What is that going to look like? We'll talk about some of those best practices in just a moment, but a big one is to make sure that the IP address space is not overlapping with your other virtual networks. And we'll discuss why that is in just a moment. Some other considerations are your subnet as well. We'll talk about that further segmentation along with your region, security, and connectivity. So that is all coming in today's session. So when we talk about our virtual network, what are some of the capabilities? You'll see a common theme across each of these bullets is the communication. And that's because by default, this is what we want to use to enable our resources to communicate securely. You should also know that when you create your virtual network within Azure, it is going to have a private IP address. And we'll talk about what those addresses are going to look like. You may be wondering, well, how would I create a public IP address? And that is coming later on. But at its core, you'll notice the first three bullets here are enabling the communication. So first is for our internet. So by default, all resources in our virtual network can communicate outbound to the internet. You'll also notice communication between our Azure resources. So this is things like our virtual network, along with something known as a service endpoint that we can configure and associate with our subnet, which is configured and associated with our virtual network. The point of a service endpoint is for additional security of your Azure resources. And the service endpoint is utilizing what we call our Microsoft backbone. But also for this communication of our resources, we're going to discuss peering. Hey, how do we connect these virtual networks to one another so that they can communicate? Because by default, the virtual networks on its own are not able to communicate until we implement something such as VNet peering. You'll also notice in our third bullet, we have communication between our on-prem resources. Maybe we want to create a hybrid type of solution, and we're going to talk about some of those different options with the use of a VPN gateway. The last two, we have our filtering network traffic. You may be familiar with the use of network security groups or NSGs. This is going to allow you to create inbound and outbound rules. And this is something that you associate at the subnet level and or at the network interface level. And we'll talk more about the subnet and how it's associated with the network, virtual network in just a moment. And lastly, we have our routing. And we're going to discuss routing more in depth, but specifically we have two types of routes within Azure. Now, I mentioned to you before that when you create your virtual network, you're going to specify an address space. So this is where that planning is really going to come into play, because when you create a virtual network, you want to ensure that the following virtual networks that you create do not have an overlapping IP address. That is just a best practice, because when we talk about enabling the communication of those virtual networks through something such as peering, you cannot peer virtual networks that have an overlapping IP address range. So this step here, not only as far as ensuring non-overlapping, but also, the step of allocating the number of addresses that you want for your virtual network itself. So I mentioned to you before that your virtual network is going to have a private IP address, and the 3 bullets here are outlining what that form may look like. So it may start off with this 10.0, it may be 172.16, it may also be 192.168. So if we were to take this, we'll take a look at this example in just a moment, but essentially I could have the same private IP address in my environment, and Erica also has the same IP address range in hers because it is private. Of course, it's going to look a little different for something like a public IP address, but we'll discuss more in just a moment. The last thing that I'll mention is that when you go in and you create your virtual network within Azure, specifically within the portal, you're likely going to see this 10.0 type of format. Typically, there's some sort of default value that's provided for you. You can, of course, change that. But I think what's most important on this slide is to understand that the IP address may also take the 172 or the 192 format as well. Now, next is the naming. This sounds very basic, but it's pretty important to have some sort of naming convention, not only for your Azure Virtual Network, but honestly across each of your Azure resources. And this is so that you're able to easily identify why the resource was created, who was created by. You'll even notice in this example here, we have the region of our resource and the instance number. The other benefit here is from a maintenance perspective. Let's say you're using something like Azure PowerShell to query your resources. Maybe you start off with this, you want to understand all of the resources of this PIP and SharePoint, followed by some of the different environments. It makes it easy to query each of your resources. And the reason we're mentioning naming here is because you need to specify a name for your virtual network. That's similar to naming, a variety of Azure resources. Another key piece is your region and subscription. So we're going to talk more about how regions come into play when we discuss peering, but really this is basic information that you need to supply. So you need to supply a region generally for most Azure resources, and that goes the same with our virtual network, along with our Azure subscription. Our subscription is essentially our billing boundary. It's a way that you're paying for your resources, and it's required in order to create a resource. Now, you may be wondering, thinking to yourself, hey, earlier she mentioned that our virtual network is free. So why do we need this subscription, which I just described as a billing boundary? It's generally required regardless of the cost of the service. So across each of your resources, you need to supply a name, you need to supply a subscription, a region, and something that we don't have on the slide is what's known as a resource group. The resource group is how you organize your resources. Those 4 key pieces are pretty basic across each of our Azure services. Now, one of the last pieces is this concept of an availability zone. Essentially, an availability zone is one or more data centers with its own power, cooling, and networking. This is especially helpful because we have a variety of Azure regions. So I tend to go with East US as that's where I'm located. But let's say I went with East US. East US is made up of a variety of availability zones, which is one or more data centers. So if, let's say, a data center were to go down in East US, it's not necessarily going to impact the region because there are additional data centers that make up that region. Now, specifically, when we take a look at availability zones, we have 2 different flavors of this. We have zonal and zone redundant services. I'm going to take a pause for you to think about what those 2 may mean to you. So think about zonal, zone redundant. Okay, so with zonal, this is you manually specifying the zone of your resource. So you would see that with, we're going to talk about public IP addresses. We'll see that in just a moment. You may also see zonal being used with your virtual machine. So this is me specifying I want my virtual machine to be in zone 1 or zone 2 or zone 3. And that's really the level of visibility that you have as far as saying zone 1, 2, or 3. Now, the second option is zone redundant. So rather than you specifying the particular zone, we're going to have replication across 3 availability zones. So you would see this, especially with storage accounts within Azure that utilize geo-replication. The last thing that you do want to be aware of is to ensure that the region that you have deployed your resource to does in fact support zones. For the most part, they are well supported, but that's something that you want to plan for and consider. Okay, so we've talked about, some of the first steps with creating our virtual network within Azure, but specifically, if you wanted to, actually go in and create that virtual network, you can use the Azure portal, which I highly recommend if you're just getting started, because it has a very nice user interface. And in the words of someone I previously worked with, they were mentioning that it's really challenging to fail because I would say it's giving you guidance step by step. You can, of course, also use Azure PowerShell or Azure CLI. Now, kind of incorporating all of what we've discussed, what is this virtual network actually going to look like? Well, we need to have a name. And for my example here, I'm not going to be very original. And my name of the virtual network is called VNet. And going back to the address range, that's pretty important when it comes to planning, making sure that you don't have the overlapping. But what does that actually look like? So for my virtual network, this is going to have an address range of 10.1.0.0/16, which essentially means that I'm allocating 65,536 addresses for my virtual network, which is quite a lot of addresses, which is where that subnet comes into play for that further segmentation of these 65,000 addresses. So the subnet is something that you are going to configure and create as you are creating your virtual network. And your subnet, essentially, if we were to take a look at this graphically, let's pretend each of these boxes are pretty even. They're all representing a subnet. And this subnet it is important for the subnet to have an address range within the virtual network address range. So it could be something like 10.1.0.0/24. And you may be wondering, okay, well, what does this /24 mean? Well, if we break this down, what we're saying is we're allocating between 10.1.0.0 and 10.1.0.255. So we're saying that we're allocating 256 possible IP addresses. Now, again, the benefit to using the Azure portal, and something that you may already know, is that 5 addresses are going to be reserved by default per subnet. So really, we have 251 addresses for this one subnet within my overall virtual network. And these are the planning and the steps that you want to consider before you even create your virtual network, whether that's through the portal, through PowerShell, or the CLI. Now with that, I will go ahead and pass the mic over to Erica to discuss some of our public IP services.
Thank you so much, Jordan. I think that's a really great basic understanding of the Azure Virtual Network and subnets. So next, we're going to be covering public IP addresses. So we'll talk about the requirements for IP addressing when you're integrating your Azure network with an on-premise network. And we'll also explore some of the constraints and limitations for both public and private IP addresses in Azure. So to support your network that exists in both places, on Azure in the cloud and also on-prem, you have to configure IP addresses for both types of networks. So an example of a public network would be like the internet that uses public IP addresses, while a private network, which is your Azure Virtual Network, which essentially is like an isolated island that is not connected to anything unless you implement something like peering, those use private IP addresses, and those are not routable using public networks. So when we talk about public IP addresses, these can be created with either an IPv4 or IPv6 address, and they can be dynamic or static. And we'll go in through the differences between a dynamic and static IP address in the coming slides. So these public IP addresses also enable your Azure resources to communicate outbound to the internet and also with public facing services in Azure. Public IP addresses are also dedicated to specific resources until they're unassigned, and they're manually unassigned by a network engineer in your organization. So if a resource does not have a public IP, Azure would dynamically assign one to allow that resource to communicate outbound through network address translation or NAT service, which we'll cover later on in this session here. So these are some of the examples that in Azure Resource Manager, these are some of the services or resources that use public IP addresses. So a few of them that I'll call out here, we did talk about like their NAT gateways, virtual machine network interfaces, firewall. So there's a whole list of them. And if you want to learn more about them, you can click on this link, or you can type in this link or use the QR code to be directed for this list of resources as they're associated with their public IP addresses. So we did talk about public IP addresses. So I did mention that you can use either an IPv4 or IPv6 address. The differences between a dynamic and static IP address is that for dynamic, I mean, with the, I guess with the description, it changes over an Azure resource's lifespan. So it's not going to be the same IP address. This is also allocated whenever you create or start a VM. So you'll have an IP address there, and the IP address will be released once that VM is stopped or deallocated or deleted. Dynamic is the default allocation method that we use in Azure, but if you do prefer something that does not change over the resource's lifespan, you can opt to explicitly set your allocation method to static. And I guess the complete reverse of that dynamic, capability is that the IP address is assigned and released only when the resource is deleted. So you're not going to have IP addresses changing as you would in the dynamic offering. So that's the difference. Depending on what your needs are for your environment, you may opt to, want to have a static IP address versus a dynamic one that will change. So this puts us at our knowledge check. Just want to make sure that everybody is ready to participate. What we're going to do is we're going to move over to the question here. And so the question here is, what is the difference between a static public IP address and a dynamic public IP address? And hopefully this is still fresh in your memory as we just went over this, but I'll go over the answers here as we give folks time to respond. Just a reminder, you can use your mobile device to participate in this poll, or you can put in https://aka.ms/polls, and this will take you to the site that allows you to participate in this poll. So the question again, what is the difference between a static public IP address and a dynamic public IP address? A dynamic IP address remains the same over the lifespan of the resource to which it's assigned. B, a static IP address can use an IPv4 address only. And C, a static IP address remains the same over the lifespan of the resource to which it's assigned. So those are your three options here. We have the ability to see some of the polling. So yeah, let's see those responses come in. We're seeing, yeah, keep them coming. We're seeing a few votes coming in. And Jordan, are you able to see the responses? I'm curious about if you have anything surprising. I see we have 83% of our votes going in one direction. And yeah, I mean, I think I guess if you think of the naming of dynamic versus static, it can be just kind of think about what does those words means, and yeah. And I'll just give a few more seconds for folks to cast their vote, and then we can go over and click over to the response, or we can review the answers and responses. So yeah. So yeah, thank you everyone for participating. So I'm going to reveal the answer now. And I think we had about 90% of our votes have selected C. So the difference between a static public IP address and a dynamic public IP address, static IP address remains the same over the lifespan of the resource to which it's assigned. So static, it will stay the same, versus dynamic, which implicates or implies that there's some change. So when you do look through these responses, just be sure that you're making the connections between why dynamic IP addresses, like it wouldn't remain the same because as we mentioned earlier, that it would change depending on when you start and stop a VM. And then as far as response B, we did mention that you can use an IPv4 address or an IPv6 address for both of these public IP addresses. So thanks all for participating. And yeah, so moving over to how do you choose the appropriate SKU for your public IP address. So there is two options you have. There's basic and standard. All public IP addresses are created before the introduction of these SKUs are considered basic SKU public IP addresses. So if you've already had your virtual network set up, you may notice that they are considered in this classification basic, as this occurred before we introduced the standard SKU. So you can take a look at this table. This is also listed very nicely in the Learn Live module. So, if you really want to dive in and use it as a rubric for deciding which SKU that you'd like to, have your IP addresses built, built off of, then I think this is a good way and a good flow for making that decision. So I'm going to move on because there's a lot of content here, but you can also notice that there's a lot of options as far as standard IP addresses versus what's offered on the basic SKU. However, I think a major difference is that for the standard SKU, the allocation method default is static, while on basic you can use both dynamic or static. So this is a really good resource. And as I mentioned before, it is on the Learn Live module. So you can definitely go back as you go through this content and define which one makes the most sense for your environment and your needs. So next, just a brief listing of, what are the components of a public IP prefix. So they are assigned from a pool of addresses in each Azure region. You can create a public IP address prefix in an Azure region and subscription by specifying the name and the prefix size. So the prefix size is the number of addresses that are available for use, and the public IP address prefixes can consist of IPv4 or IPv6 addresses. So in regions with availability zones, the public IP address prefixes are created as zone redundant or associated with a specific availability zone. And after the public IP prefix is created, you can then create public IP addresses. In addition to that, we also have the custom IP address prefixes, or this is called BYOIP. And this can be used in the same way as Azure own public IP address prefixes. You can associate your custom IP addresses to Azure resources, and they can interact with internal or private IPs as well as VNets. Your custom IP address prefix can also reach external destinations that are outbound from the Azure Wide Area Network, or WAN. So next we have another knowledge check. So make sure you have your mobile device or your browser ready. Let me go to the question. So here's our question. Which of the following statements about Azure public IP addresses is correct? And these are your options. A, standard public IPs are dynamically allocated. B, basic public IPs are supported in availability zones. And C, public IP addresses allow internet resources to communicate inbound to Azure resources. So give some time for folks to cast their vote. Reminder that you can do this on your browser at aka.ms/polls, or you can use your QR code reader to scan this QR code on the screen and it'll take you directly to the poll site. And I'm seeing some votes come in.
Yeah, I'm also seeing some votes as well. Seems pretty heavily towards one particular answer.
Yeah. So I think we can just give it a few more seconds for folks to cast their vote. And if you're interested in, using the chat to kind of justify why you've selected an answer, feel free to have a conversation there. I think it's good if we're able to kind of use the chat and this live format to be able to discuss, what your kind of thinking is. So I think we've got about 90% of the votes in one answer. We have 11% in the other. So yeah, I'm going to move to the responses and also the answer. So the correct answer for this one is C, public IP addresses allow internet resources to communicate inbound to Azure resources. So an IP address, as I mentioned earlier, is assigned from a pool of available addresses based on the location of the resources. So yeah, thanks everyone for participating. I think we have another knowledge check coming up. So make sure you have your mobile device or your browser ready. I'm going to move over to the question now. So the question is, application owners need to use dynamic IP addresses for specific resources on their VNet. Which SKU must they choose? So I think if you kind of reflect back on what we've talked about, we did look at that table, that grid that showed us the differences between the SKUs of standard and basic. So yeah, I think if you have the Learn module up on your computer, there is the same table with that classifications there, so you can feel free to refresh your memory there. But if not, I think it's a good opportunity to kind of exercise your memory and see, which one was it. So lots of votes coming in here, and we'll just wait a few seconds more to see. It seems like there's a good distribution of responses for each of these choices. So yeah. Yeah, so this will be interesting to unpack, I think. So just a little bit more time. And okay, so I think we have, based on what I'm seeing in the polls, we have about 55% of votes that are selecting B, standard SKU. So I'm going to flip over to the answer here. So the answer here is actually A, basic SKU. So I think flipping back to that table that I'd shown, we saw that standard SKU, the allocation method, was static, while basic had more options as far as depending which IPv4 or IPv6 you chose. So yeah, this is the correct answer. Basic SKU public IPs can be assigned by using static or dynamic allocation methods. So there's a little bit more flexibility there. However, I think the standard SKU does offer more perks, I guess, for some other categories. So thanks all. And next, um, just a reminder that in the Learn Live, or we are doing Learn Live now, but in the learning modules themselves, there are some exercises, and this one is probably a really good one to go through. It's an interactive lab simulation that's available in the module. And I just want to do mention that this doesn't require you to have an Azure subscription to try out. So please do take advantage of this. It's a really good opportunity to kind of get into the motions of designing and implementing your VNet in Azure. And it comes with a list of tasks and a really nice interface that guides you through the process of how to do these, how you would go through these exercises. So please do, revisit the learning module after this course or after this session, and then take your time to go through these lab simulations. So then the next topic we're going to cover here is how to design a name resolution for your virtual networks. So depending on how you use Azure to host your solutions, whether it be IaaS, infrastructure as a service, or platform as a service, or any other hybrid solutions, you might need to allow your virtual machines and other resources deployed in your virtual network to communicate with each other. So you can enable communication by using IP addresses, as we talked about before. However, sometimes it's easier to use names that can be, more simplified and easy to kind of remember what they stand for, as well as these names are not dynamic and they won't change. So there's no surprises there. So DNS is split into two areas. There's a public and private DNS, and these resources this is used for resources to be accessible from your own internal networks. So here's the breakdown here. Public DNS, that resolves names and IP addresses for resources and services accessible over the internet, such as your web servers, versus private DNS. So these are used for resources accessible from your own internal networks. So Azure offers a hosting services called Azure DNS for DNS domains that provides name resolution using Microsoft Azure's infrastructures. So these are some of the components that are along with this Azure DNS. It's hosted on Azure's global network of DNS name servers. It uses anycast networking. Each DNS query is answered by the closest available DNS server. So this gives you faster performance and high availability for your domain. So a better user experience, I believe. And it's a reliable, secure DNS service to manage and resolve your domain names in a VNet without you having to add a custom DNS solution. So this is something to consider as your public DNS service. And yeah, some other considerations you want to think about when you're thinking about this is, what the name of the zone is. It has to be unique within your resource group, and the zone must not exist already. The same zone name can be reused in a different resource group or a different subscription. Um, where there's multiple zones that share the same name, each instance will be assigned a different name server address. The root parent domain is registered at the registrar level and pointed to the Azure NS, and child domains are registered in Azure DNS directly. So when you are thinking a little bit more closely about like Azure DNS, these are some of the considerations that you might want to think about as you start to plan your network environment. This is a note that you don't have to own a domain name to create a DNS zone with that domain name in Azure DNS. However, you need to own the domain to configure the domain. So that's one of the reminders that the Learn Live module does let you know as you kind of go through these considerations as far as planning and planning ahead for your network. So when you're delegating your domain to Azure DNS, you first need to know the name server names for your zone. And each time a DNS zone is created, Azure DNS allocates name servers from a pool. So once the name servers are assigned, Azure DNS automatically will create an authoritative NS record in your zone. So once the DNS zone is created, you have the name servers and you need to update the parent domain. Each registrar has their own DNS management tools to change the name server records for a domain. In the registrar's DNS, you'll edit the DNS records and replace the NS records with the ones Azure DNS created. Another note here is that when you are delegating a domain to Azure DNS, you must use the name server names provided by Azure DNS. So you should always use all four server names, regardless of what the name of your domain is. So this is just some guidance as you start to implement this into your environment. Another topic to think about is child domains. So you can set up a separate child domain by delegating a subdomain within the Azure DNS. So for example, you can configure a separate child zone for within your DNS, depending on what your needs are. And the protocol for setting up this subdomain follows the same process as the typical delegation that we discussed earlier. But the only difference is that NS records must be created in the parent zone rather than in the domain registrar. And just a note here, parent and child zones can be in the same or different resource groups. So depending on what your needs are and how you might want to keep that in mind when you're configuring both the parent and child zones. So DNS record sets. This differs a bit from the individual DNS records. So here is an example on the portal about how you would find that or how you would add a record set. So the record set itself, it's a collection of records in a zone that have the same name and are of the same type. You cannot have two identical records within a record set. And empty records can also be created, but they do not appear on the Azure DNS name servers. Private DNS services, this is a ability to resolve names and IP addresses for resources and services using one of these methods. So there are three here. There's Azure DNS private zones, Azure provided name resolution, and name resolution that uses your own DNS server. This would cover any scenarios where your resolution needs go beyond what is provided by Azure. So depending on what what resources that you need to communicate with each other will indicate the type of name resolution that you use. So just keeping in mind when you are thinking about integrating or putting DNS services into your environment, really think about what your use cases are and which ones align closest to fulfilling them. So with an Azure provided DNS, we provide our own default internal service, and it provides an internal DNS zone that always exists. It supports automatic registration and requires no manual record creation. And this is created when the VNet itself is created. I think one thing to note, it's also a free service. So we do provide name resolution at so Azure provides name resolution, provides only basic authoritative DNS capabilities. So if you're using this option, the DNS zone names and records will be automatically managed by Azure itself, and you will not be able to control what the DNS zone names are or the lifecycle of their records. So this is something that is managed by Azure itself. So it's something to keep in mind when you are thinking about these options. So private DNS zones in Azure, they're available for internal resources only. They themselves are global in scope. So this means that you can access them from any region, any subscription, any virtual network, and any tenant. So as long as you have permissions to read the zone, you can use it for name resolution. And private DNS zones are highly resilient. So this means they're replicated to regions all throughout the world, and they are not available to resources on the internet. So this would be a good solution if you require more flexibility than the internal DNS allows, and you can also create your own private DNS zones. So some of the capabilities listed here is that it allows you to configure your specific DNS name for a zone. You can create your own records manually whenever it's necessary to do so. You're also able to resolve names and IP addresses across different zones, as well as across different virtual networks. So there's a little bit more flexibility than the internal DNS allows. So as far as creating a private DNS zone, this is just a view of what it looks like on the portal. As you can see here, you can use the search bar to type in private DNS zone, and then you'll get to that service, click there, and then this is how you would get started with that. There's also the ability to create these using Azure PowerShell or Azure CLI. So depending on what you're most comfortable with, there are multiple avenues for you to be able to create this, service and spin it up. So in Azure, a VNet represents a group of one or more subnets as defined by a CIDR or a classless interdomain routing range. Resources such as VMs are added to the subnets, and at the VNet level, the default DNS configuration is part of the DHCP assignments that are made by Azure, specifying the special address, which is 168.63.129.116 to use Azure DNS services. But however, if you need to, you can override the default configurations here by configuring in an alternate DNS server at the VM NIC. So this diagram here kind of outlines what this would look like. There are two ways to link your virtual networks to a private zone. One of them is registration, the other is resolution. So each VNet can link to one private DNS zone for registration. However, there is a limit, which is up to 100 VNets can be linked to the same private DNS zone for this registration way. For resolution, there may be many other private DNS zones for their different namespaces, and you can link a VNet to each of these zones for name resolution. However, there is another limit. Each VNet can link up to 1,000 private DNS zones for name resolution. So depending on how and what your use case is, you may decide on which of these two ways that you'd like to link your virtual network to this private DNS zone. So if you have an external DNS server, so for example, an on-premise service or server, you can use custom DNS configurations on your VNet to integrate them. And organizations will often use an internal Azure private DNS zone for auto registration, and then use a custom configuration to forward these queries to external zones from an external DNS server. So when we think about forwarding, there are two types here. Forwarding specifies that another DNS server or an SOA for a zone resolve the query if the initial server cannot. The second point is conditional forwarding specifies a DNS server for a name zone so that all queries for that zone are routed to the specified DNS server. So this is just a diagram here that kind of that maps out what the conditional forward looks like. So again, that's a lot of information. I don't expect everybody to really resonate in this call, but I hope that you do take time to look at this interactive lab simulation available on the Learn Live, on the learning module, in order to kind of get a better understanding of how to do this in practice. So please do check this out. I think it's probably a lot easier to grasp it when you're learning by doing. So just want to call that out here. This is a great exercise for you to focus on. So I'm going to pass it over to Jordan to talk to us about virtual network connectivity.
Awesome. Thank you, Erica. And before I go into discussing virtual network peering, I did want to just highlight and maybe reiterate some of the topics that you mentioned, specifically relating to the previous poll question on the concept of a SKU. SKU stands for Stock Keeping Unit, and it's used across Azure resources, so something like a public IP address. But the reason I mention this now is because I saw a comment in the chat which was essentially mentioning how the SKU names can be a bit confusing. And I'd agree. I also saw Raman sharing some ways that you may be able to easily identify, the differences just with the name. Just with the training team that I work with, some fellow colleagues, I guess give a good way of remembering, okay, the difference between basic and standard. You can think gold standard as an example, where gold standard is providing you with essentially all of the bells and whistles. So that might be a great way of understanding the difference between basic, which doesn't have all the bells and whistles, versus the gold standard. So let's go ahead into configuring our network connectivity. So this goes all the way back to what we first discussed with creating our initial virtual network. And this is where that planning comes into play. So in this case, rather than having one particular virtual network, we now have multiple virtual networks. Let's say 2 as an example, and we want to enable the communication of those 2 virtual networks. By default, they cannot communicate, but we can use something such as virtual network peering to enable the communication of those virtual networks. Specifically, we have 2 different ways that we can do this. One of them is known as regional VNet peering, and the other is global VNet peering. Now, before I go into the difference between each of them, what you should know, and a benefit to using Azure, is that when you configure, whether that's regional or global, they're configured the same way. So with regional, this is describing me peering 2 virtual networks that reside in the same region. So something like I have 2 virtual networks that both are in East US and I want to peer them with one another, versus global. As the name suggests, this is me peering across regions. So I have one virtual network in East US and another virtual network in West US, and I want to peer them to one another. I mentioned before, the process of creating that peering relationship is the same regardless of if it's across regions or within a particular region. Now let's take a look at an example here. So this goes back to, hey, we highly recommend that you have some sort of plan in place before you create your virtual network environment. And that's because when it comes to peering in particular, you need to make sure that the virtual network address spaces do not overlap. Why is that? Because you cannot peer 2 virtual networks that have overlapping IP address spaces. So in this example here, we have 3 virtual networks. VNet 1 is in, let's say, East US. VNet 2 and VNet 3, let's say, are in West US. And when you establish this peering relationship, let's take VNet 1 and VNet 2 across regions, you'll notice that this is going to be bidirectional, meaning we're peering from VNet 1 to VNet 2, and we're also peering from VNet 2 to VNet 1 as well. Now, while this is going to be bidirectional, when you actually establish that peering connectivity, you only need to do the configuration once. So while it's going both directions, you as the engineer, the administrator, really only need to navigate into either VNet 1 or into VNet 2. And that's because when you navigate into one of those virtual networks, you're going to select peering, and this is a screenshot of what it's going to look like within the Azure portal. So first we have this peering link name. So it goes back to having that naming convention. You want to have it something meaningful. So if I were looking to peer VNet 1 to VNet 2, I'd want to give it the name of something like VNet 1 to VNet 2. And then you'll notice that we have this traffic to remote virtual network. I want to keep this as the default for allow. I also want to allow traffic forwarded from remote virtual network, keeping everything as the default. You'll also notice that we have this virtual network gateway. Right now, we haven't yet discussed that, so we'll keep it for none. And then lastly, we have this remote virtual network peering link name. The remote virtual network is referring to the virtual network that you're looking to peer to. So if we navigated into VNet 1, the remote virtual network is going to be VNet 2. So the name that we'd want to provide would be something along the lines of VNet 2 to VNet 1. Again, as an example, having something meaningful so that you understand that relationship and what's going on here. Now, I also mentioned here with this virtual network gateway, we don't have that. We haven't discussed that yet. So we're going to keep it for the default for none. But what if we did have a virtual network gateway? Essentially in Azure, we have a VPN gateway, and it offers us 3 different connection types. So the first one that we see here is our site-to-site. This is us connecting our on-prem environment to Azure. We also have VNet to VNet, which is very similar to the concept of virtual network peering. The difference being that with our VNet to VNet, this traffic is going to be encrypted versus something like peering, which is using the Microsoft backbone. So if you're ever trying to remember what's the difference between peering and VNet to VNet that uses a VPN gateway, think encryption. And then lastly, we have our point-to-site VPN. I would say this is what most people think about when they think of what a VPN means. This is us connecting our devices to an Azure Virtual Network. So you can think remote work as an example that utilizes a point-to-site VPN. Now, this diagram on the right here has us thinking about how we might want to design a solution that's incorporating not only peering, but also what we've just discussed with our VPN gateway. So on the right here, we have what's known as a hub and spoke network topology. Specifically, Contoso and Fabricam are our spoke virtual networks, and this is typically where you're going to host your workloads. And we have our hub virtual network that includes a virtual appliance and a VPN gateway. So a couple things to highlight from what we've discussed so far. You'll notice within our hub virtual network, we have subnets. We talked about that initial design and consideration, but for something like a VPN gateway, you'll notice that, hey, we actually have a specific subnet for that VPN gateway. And as a best practice, you shouldn't put other resources in this gateway subnet, hence the name, but just as an FYI as you're configuring your own environment here. Now, the other thing with this hub and spoke network topology, the benefit here to not only utilizing peering, but also a VPN gateway, and something that's not necessarily labeled on here is something known as a user-defined route. We'll talk about user-defined route in just a moment, but the benefit here is enabling full connectivity, specifically among our spoke virtual networks, as an example. So between Contoso and Fabricam, rather than just relying on peering, we can implement the use of peering in addition to this VPN gateway and our user-defined route, so that, let's say later down the line, I wanted to add another workload that I didn't initially anticipate, essentially another virtual network, and I wanted to enable full connectivity with my existing environment. All I would really need to do is peer that new virtual network with our hub virtual network. Now, the last thing that I will mention with this particular architecture here is in relation to this VPN gateway. If you're trying to consider, okay, should I go with a VPN gateway or maybe not? What are some of the pros? And one of them being that we have the ability to connect to our on-prem environment for that hybrid connectivity. Okay, so we're going to come back to many of these concepts, specifically relating to what I mentioned with our user-defined route. We'll talk about what exactly that means. But before we do that, let's take a pause for our knowledge check based off of some of what we've discussed so far. So our first question here is, when one needs the resources in one VNet to communicate with resources in a subnet in a different VNet, which Azure network feature should be used? Is it A, an internal DNS? Is it B, Azure availability zones? Or do you think it's C, VNet peering? Let us know in the poll. And again, as a reminder, you can scan the QR code or navigate to the ak.ms/polls link. What are we thinking here? I'm seeing some results coming in. It looks like we're on the right track, which is great to see. We'll give it a couple more seconds here as the votes are populating. Alrighty, nicely done. We can go ahead and take a look at our results here. Nicely done. 100% got this correct in that we want to use virtual network peering to enable that connectivity of our virtual network, specifically with resources in a different subnet. Some of these other choices, internal DNS doesn't really relate here. And as it relates to our availability zones, that's ensuring that our solution is highly available, which is great, but again, doesn't relate to this particular question. So overall, nicely done. Let's take a look. We have another knowledge check question here. And the question is, when configuring global peering, what changes will occur in the peered VNets? Is it A, a peering entry is added to the routing table in the source VNet only? Is it B, all traffic on the VNet must be routed through a gateway? Or is it C, a peering entry is added to the routing table in each VNet? Now, I will mention we've discussed the concept of peering, but we haven't discussed this concept of routing table just yet. So we will in just a moment. But I did mention, hey, the fact that our VNet peering is going to be in both directions, that hint should help you in choosing the most appropriate answer here.
Yeah, Jordan, I think that's a really great hint. I think this one is a tricky one, but I think what you just reshared here should give that like clue, I guess, of where we would go, what we'd be going to.
And it's looking like we're swaying in the right direction, which is great. I'm seeing 100% so far. We'll give it a couple more seconds as the votes populate. Alrighty, let's go ahead and take a look at the results here. Nicely done, 100%. We know that a peering entry is added to something known as a route table, which is what we'll discuss now. What is a route table? But specifically the hint of, hey, when we establish this peering connection between these two virtual networks, it's going in both directions. So it makes sense that there's an entry in both of the virtual networks. Before we go into routing, as a reminder, we have lab simulations included within this Microsoft Learn module that I highly recommend that you check out. And that way you're able to get experience with many of these technologies at your own pace and in your own time. Okay, so I've kind of previewed this concept of routing, but let's actually talk about what exactly this means. So within Azure, we're going to have two different types of routing. Essentially, the default routing is known as system routes. And that's because Azure is routing traffic between all your subnets within a virtual network by default. So this default, this system route, is something that we cannot change, we cannot remove, but we do have the option to, hey, we can create our own custom routes. And that's through our user-defined routes, which we'll talk about. But before we do so, what are some of those default routes look like? Well, first we have our virtual network where that address prefix is going to be determined based off of the virtual network itself. And this is what's going to route traffic between your address ranges within a virtual network address space. Now, you'll also notice that we have some other options. So the second one being internet, where Azure is going to route traffic for any address that's not specified by an address range within a virtual network to the internet. And then the last three that we have, where you'll notice the next hop type is specified as none. And this essentially means that when the next hop type is specified as none, the traffic is going to be dropped. Why is that the case for these last three address prefixes? And that's because these last three here are reserved for private use, according to RFC 1918, along with RFC 6598. So this is our default. We also have some optional default routes. The reason it's saying optional is because this is something that you would have to essentially opt into. So if you enable particular Azure capabilities, Azure is going to handle that routing for you. So what does that look like? Well, hey, we discussed VNet peering as an example. And this goes back to that previous review question that we saw. So when you establish a peering connection between your virtual networks, you're going to see this new, you're going to see a route added to that route table in both virtual networks. And that's because it's bidirectional. Now you also notice that we have our virtual network gateway, which we've previously discussed in relation to the VPN connection types that are available. And lastly, something that we haven't yet discussed is this concept of a service endpoint. The benefit to a service endpoint is that it's going to provide you with additional security for your Azure resources. And it's utilizing the Microsoft backbone. So there's a variety of service endpoints that you can enable within your subnet, and that subnet is going to be within your virtual network. So an example would be something like a storage account, and you're going to associate that at the subnet level. The benefit here as it relates to our route table is that Azure is going to manage the addresses within the route table despite if your Azure services, the IP address that's associated with your Azure service changes. So that's a benefit as it relates to our service endpoint itself. Now I mentioned, hey, we have two different types of routing. We reviewed system routes, but hey, what if we want to create our own customized route? That's our custom route, which we use to describe as a user-defined route. So this is what's going to allow us to override the default routes, or what we can do is add routes to a subnet route table. The benefit here is that it's going to give us more precision when it comes to routing our traffic. So an example here that I like to give is really an analogy. You can think of, let's say, a system route similar to, let's say, a GPS, which is going to give you really the default route you're specifying from point A to point B versus something like a user-defined route. Hey, maybe I have some pit stops that I want to take along this route. This is me customizing that routing experience. Now, with our user-defined route, you're going to see some similar next hop types to what we saw with our default routes. So you're going to see next hop types such as a virtual appliance, and this is going to typically run a network application such as a firewall or an Azure firewall, and we saw that as an example within a hub and spoke network topology. That was the graphic on the right where we saw Contoso and Fabricam. You may also see the next hop type of a virtual network gateway where it's specifically going to be a VPN. You may also see none, which we saw before as well, which if you recall, none essentially means that your traffic is going to be dropped. Of course, we have a virtual network. And the benefit to using a virtual network when you are customizing your routes as that next hop type is for you to override the default routing. And then lastly is the internet. This is you explicitly routing traffic to the internet. So keeping in mind those 5 valid next hop types when you are creating a user-defined route is pretty significant. Now, this last piece here is relating to essentially putting each of the pieces of the puzzle together. So in this case, we have 3 subnets. We have our front-end subnet, we have our DMZ subnet, and we have our back-end subnet. And what we want to do with that user-defined route, I mentioned, hey, we want to make some pit stops. We want to essentially define this traffic flow. So we want our traffic to flow from the front end through the virtual appliance, which is within our DMZ, through to the back end subnet. And you'll notice that we have our virtual appliance. So this could be for routing. You may also see this with an Azure firewall. This is one example of when you may want to configure something like a user-defined route. But you would also see this in another graphic that we saw earlier. So again, I mentioned, hey, hub and spoke network topology. Not only are we implementing peering in our VPN gateway, but we also want to use a user-defined route in order to allow our spokes to have full connectivity between each of them. Now with that, we're going to go ahead and pass the mic over to Erica to discuss hey, what are some ways that we can actually create a routing table?
So thanks, Jordan. So what we see here on this screen is just a shot of what the portal view looks like. So when you are creating a route table, you can see there are some fields here that are required, such as your subscription, your resource group. As far as your instances, you would have to let us know what your regions and the name of the route table, as well as your if you decide either to yes or no, propagate the gateway routes. So your routes will automatically be added to the route table for all of your subnets when you do indicate yes, virtual network gateway propagation enabled in that selection there. A note is that when you're using ExpressRoute, the propagation ensures that all the subnets will get that routing information to the routing table. Additionally, when you create a custom route, you can see here in this image here that this custom route itself. It will be applied to this address prefix that's listed here, which is 10.0.1.0/24. This is a private subnet, and then you can indicate what the next hop is. So you do have a lot of options here. In this example, we are picking an NVA or a network virtual appliance, but you can indicate if you want a virtual network gateway, a VNet, an internet, or none itself. So these are some of the options that you can think about once you are creating that custom route. So the last step, so when you are associating the route table, in this image here, you want to associate the public subnet with the new routing table. By default, when you're using system routes, the traffic itself goes directly to the private subnet. But however, when you're using a user-defined route or UDR, you can actually force the traffic through the NVA or the network virtual appliance. Um, so we're going to kind of look through what it means to actually do some forced tunneling in this next example or this next slide here. So forced tunneling itself, it lets you direct or force all internet-bound traffic back to your on-premise location. And this is using a site-to-site VPN tunnel for inspection and auditing and monitoring. So this is pretty critical as it is a security requirement for most enterprise IT policies. And if you don't configure forced tunneling, the internet-bound traffic from your VMs that are on Azure, they'll always traverse from the Azure network infrastructure directly out to the internet. So this does not give you the option to allow you to inspect or audit the traffic, which is why this forced tunneling is a good way in order to have that ability. Um, and just to note that unauthorized internet access can potentially lead to some information disclosure or other types of security breaches. So making sure that you are configuring forced tunneling, and you can use Azure PowerShell to do this is very important and crucial for your network security. I do want to note here that it cannot be configured using the Azure portal. It's a good idea to kind of get more familiar with PowerShell in order to be able to set that up for you. And Azure Route Server. So this simplifies the dynamic routing between your NVAs and your virtual networks. Azure Route Server allows you to exchange routing information directly from the Border Gateway Protocol or BGP routing protocol between any NVA or network virtual appliance that supports this routing protocol and the Azure Software Defined Network. In VNets. So this allows you to not have the need to manually configure or maintain route tables. It's a fully managed service and it's configured with high availability. So whenever you are trying to diagnose a routing problem, there are some tips here that you can use. You can actually go into your portal and you can see here in this example that you're able to see like what the effective routes are for all of your network interfaces within the subnet. And then you can also see, Azure default routes, routes propagated from your on-prem environment to your Azure network through Azure VPN Gateway via BGP or Border Gateway Protocol. Another way you can do this is that you can actually use PowerShell to use this command, get Azure Effective Route Tables, and view your routes there. And this will allow you to get a better idea of any issues that might be happening in these routes that you've set up. So some of the steps that you may want to take when you're recognizing that there is a routing problem. So here we have it outlined here. You might want to add a custom route to override any default routes. You can change or remove a custom route that's causing your traffic to be routed to a location that is undesired. You can ensure that the route table that's associated is associated to the correct subnet. And this is the one that would contain the network interfaces that you selected. And you can also ensure that devices such as your Azure VPN gateway or any NVAs that you're using are deployed and operating as you've designed and intended them to. So this is a good resource, I think. This is also up on our learning module for this section. To kind of fall back on when you are, setting up these routes and realizing, okay, maybe something might be being misconfigured or misdirected. Being able to fall back on this resource is a good way for you to kind of get a better understanding of troubleshooting these issues. So next up, we have a knowledge check. So when you're ready, let's make sure that you folks have your polls set up on your desktop or mobile device. The question here that we have is, what type of routes enable traffic to override routes that Azure configures? So your choices are A, UDRs or user-defined routes, B, system routes, or C, default routes. And since we're coming up in our last 15 minutes, I'm going to maybe move ahead a lot quicker than normally. But it seems that as far as the folks that have submitted their responses, we are at A, user-defined routes. So this is a correct answer because when you create custom user-defined routes in Azure, they actually override the default system routes that are already in place. Or you can also add additional routes to subnet's route table, but this is the option that would allow you to override anything that's in existence or default on Azure itself.
I would also add here that when you're trying to remember, okay, what does UDR mean? Think custom versus system, you should think default. So you see system and default as two separate answer choices. We kind of refer to them as the same thing. So just calling out that UDR, we're thinking custom.
Thanks, Jordan. Great. So we have another knowledge check coming up. And this question is, a VNet is experiencing some routing problems. What would an engineer or you do to begin to diagnose the problem? A, configure every resource with a static IP address. B, view the effective routes for each NIC. C, use forced tunneling to control the traffic flow. So I'll give a few seconds to answer this question. We did go over some of the steps that one would take if they're noticing that there are some issues with routing in their network. So great. So I would say we have our poll results coming in, and yeah, it looks like viewing the effective routes for each NIC, or option B, would be the best way that you would go about diagnosing any routing problems. And again, I do want to mention that there are many options that you, or three options that you can use to be able to see effective routing. We looked at two of them. You can use Azure Portal, and you can also use Azure PowerShell and Azure CLI to review the effective routes for each NIC. So each tool has its own process, but they will all tell you which of the routes that the NIC is communicating with, and what other resources that they're connected to. So that's a good good way as far as troubleshooting any issues that are happening in your routing. So lastly, I think our topic is how to configure your internet access with Azure Virtual Network NAT, or Network Address Translation. So I guess, we understand that IPv4 address ranges are very short supply on a global scale, and they are becoming a very expensive way to grant access to your internet resources. So network address translation, or NAT, as abbreviated here, this came out of the need for internal resources on a private network to share their routable IPv4 addresses that allow users to gain access to external resources on a public network. So rather than having to purchase an IPv4 address that each resource requires in order to get access to the internet, you can use a NAT service to map outgoing requests from the internal resources to an external IP address so that the communication can take place. So NAT services provides mapping for a single IP address, a range of IP addresses defined by an IP prefix, and a range of ports associated with that IP address. It's very compatible with standard SKU public IP address resources or public IP prefix resources, or you can also combine both of those. You can use a public IP prefix directly or distribute that public IP address of the prefix across multiple NAT gateway resources. NAT itself will map all traffic to the range of IP addresses of that prefix and allow flows to be created from the virtual network to the internet. Return traffic from the internet is only allowed in response to an active flow. So this diagram itself, it shows you the outbound traffic from subnet 1, as you can see here, through the NAT gateway, and it's mapped to a public IP address on the left side, or a public IP prefix on the right side. So that's kind of how the traffic is expected to flow in this configuration. You can also define NAT configuration for each subnet within a VNet to enable outbound connectivity by specifying which NAT gateway resource to use. So after NAT is configured, all UDP and TCP outbound flows from any virtual machine instance will use NAT for internet connectivity, and you don't have to configure any other network or any other configurations because they're not necessary. So as far as scaling that, as I mentioned earlier, like it is, you don't need to do extensive pre-planning or pre-allocation of any of your addresses because NAT will scale dynamically to support those workloads. You can also use port network address translations. This is abbreviated as PNAT or PAT, and this provides, or NAT provides up to 64,000 concurrent flows for UDP and TCP respectively for each of the attached public IP addresses. Another limit that I do want to note here is that NAT can support up to 16 public IP addresses. So those are some kind of data points or limits that you want to keep in mind when you're thinking about scaling network address translation. So as far as deploying NAT, these are some of what you want to think about when you're configuring and using a NAT gateway. It is a straightforward process, but these are some areas that you want to kind of think about as you configure them. I won't read through them since we're coming up against time, but this is all listed in the learning module, so please do revisit that. And as I mentioned earlier, it is highly compatible with standard SKU resources. So some of these include the load balancer, public IP addresses, as well as public IP prefixes that we've talked about. We haven't really talked much about load balancer in this session, but there are other sessions that do cover it and other learning modules that, that will introduce you to a better understanding of how and when you would use a load balancer in your network configurations. So there are some limitations of network address translation. So I mentioned it is compatible with a standard SKU public IP prefixes, and other load balancer resources. Basic resources, like for example, the basic LB or basic load balancer, and any products derived are not compatible with NET. So basic resources must be placed on the subnet that's not configured with a NAT. So that's something you want to think about as far as when you are selecting which resources you're using and how you're configuring them. There are some that are not compatible with NAT. IPv4 address families are not supported. or I'm sorry, are supported. However, IPv6 addresses do not interact with NAT, so they cannot be deployed in the same subnet as an IPv6 prefixes and NAT. So that's another thing you want to make sure that you're only using IPv4s if you're deciding to work with NAT. NAT also cannot span multiple virtual networks at this time, and it also does not support IP fragmentation. So these are some of the known limitations. I think our product group is working on finding solutions to get to work around and also fill these gaps. So you can stay tuned as far as we announce more information about that. Yeah, so we have a few knowledge checks or a couple of knowledge checks left in our last 5 minutes. And the first one is, what is the purpose of NAT? So what is the purpose of network address translation? Your choices are: NAT enables you to share a single public IPv4 address among multiple internal resources. B, NAT allows you to assign multiple private IPv4 addresses to a single virtual machine. And C, NAT enables you to configure an external IPv4 address on each individual virtual machine. So take a few seconds to think about, what the purpose of this NAT service is. And we will go to the responses here. So the response is, or the correct response would be A, NAT enables you to share a single public IPv4 address among multiple internal resources. So it enables internal resources to share this IP address for communication outbound with internet resources. And I think we're up on our last knowledge check for today. How does NAT scale to support dynamic workloads? Your choices are: A, NAT supports up to 4 public IP addresses. B, NAT doesn't scale dynamically. You must configure NAT to scale manually by adding other NAT gateways. And C, NAT supports up to 16 public IP addresses, and for each of those uses port network address translation to provide up to 64,000 concurrent traffic flows. So I'll give a few seconds to answer this response before I'll go to the answer. I think I may have emphasized this one a little bit too much in the responses, but I also recognize there's been a lot of information that's been thrown at everyone here today. So do want to give a few hints when I can. So we have the correct response, and I see 100% of the responses that came in did select C. So this is correct. NAT does support up to 16 public IP addresses, uses PNAT or PAD, and provides up to 64,000 concurrent flows for UDP and TCP respectively for each of the attached public IP addresses. So I think everyone's done really great. Thanks so much for participating in these knowledge checks throughout the day. I think it's really great to kind of test how much information has been retained, but also want to remind you, please do go to the learning modules and go through this content a little bit more in depth and a little bit slower. We did go through a lot today and kind of breeze through a lot of really valuable content. But hopefully you'll be able to have some time to run through it at a pace that's a little bit less intense and more productive for your learning. And at this point, I'll pass it off to Jordan to close it up.
Awesome. Thank you, Erica. And again, reiterating, thank you all for taking the time to collaborate with us. I saw the comments responding on the poll. Again, we did cover quite a bit of information as a nice review. We really got started with an introduction to what a virtual network is. And then from there, we talked about some of the public IP services that are available. It is especially important to understand the different SKU options. From there, we talked about DNS. Hey, maybe we want to enable full connectivity between our virtual networks or enable our virtual networks to communicate with one another. We also discussed this concept of routing. Hey, we have 2 different types of routing that's available to us. And lastly, we just reviewed NAT with Erica. As a reminder, this QR code is taking you to the Microsoft Learn module if you want to learn more about what we've discussed with you all today, along with the lab simulations. And again, here is that ak.ms/learnlive 2023-06-01A. You can also easily scan the QR code to access that full module that goes through all of this information and more. And in the future, we have another Learn Live coming up on June 8th. We'd love to see you there. It's focusing on Azure Site Recovery and how you might want to protect your Azure infrastructure. And also, if this is your first time joining our Learn Live sessions, well, one, welcome, glad you came. But also, we have other series, other videos are part of this series that you can navigate to this Learn Live Azure Core IaaS Study Hall, aka link. But again, thank you all for your time and engagement today. It's been such a great time working with you all, and I hope you have a great rest of your day. Bye.
Thanks all, and also thanks Raman for moderating the chat, and everyone for participating and putting in your questions. I think we had a lot of great engagement today, so thank you, and hope you keep learning and check out the learning module.